In this video, we go over how to mock and what to mock during unit testing. Hey guys, welcome back to episode 5 of the Stacked Architecture series. This episode is the second part of the unit testing chapter in this little series of videos. Today we'll go over what mocking is, why we need mocking, and how to use it within Flutter unit tests. Mocking is the act of creating duplicates of a real class to simulate the required behavior. It will be an exact copy of your public-facing interface for a class, but you can control what values it returns and how it returns those values. Why are mocks important to us? When writing a unit test, you want to always only be testing the actual unit of work. This means we cannot have non-deterministic behaviors. What a non-deterministic behavior is something like using datetime.now within your functionality. When you write a test that uses something like datetime.now, it means the test will pass or fail depending on what the actual time is at that moment for the system that the test is running on. This means that the test won't always have the same conditions, meaning that it is non-deterministic by nature. With mocking, this allows you to always return the exact values that your unit would require for the functionality to be tested. So how is mocking done within Flutter? You can download the starting code under the How to Mock section. Once that completes, you can open it up in Visual Studio Code or your editor of choice. To perform mocking in Dart, I have chosen the package Mockito as the mocking framework. So navigate to the pubspec.yaml file and we'll add Mockito as a dev dependency. While that's downloading, let's talk about using mocks for development. From the previous video, there were 4 rules in the set of rules that I gave you to define a unit of work where you have to use mocks to perform the actual unit test. The first one is testing an interaction. This is when you call a function and you want to check if a service has been called. The second one is testing a conditional. The third one is for error handling, where you can mock out your exceptions. And the last one is testing how your code reacts from values from services. This is where you can use the stubbing in the mocking framework to provide the exact values that you need for your unit test to be successful. To go over the mocking and all of the setup, I will actually develop a set of functionality that is being used currently in one of our production apps. This process will illustrate you how powerful mocks are during testing as well as outside of testing by developing the business logic using only mocks and unit tests. The business requirement for the startup logic is as follows. When there's no user on disk, we want to show the welcome view. And if there's a user on disk, we want to get the current address from the database. If there's no user address in the database, we have to take them to the address selection view. This usually happens in our case when the user quits during the sign-up flow before they select their address. The fourth point is if there's an address in the database, we can navigate directly to the home view. But before number 4 is even done, we need to check that the user has the correct permissions for the app. And if the app doesn't have the permission to use the location, we have to request that location. We'll use a TDD approach as it will help you see what kind of errors can come up during unit testing and also how to solve that during your unit testing cycle. You can go to the view model test folder and create a new file called startup view model test.dart. This is where we'll write all of the tests for the startup view model. We'll make use of the snippet test_m, which will create our main function as well as the first group with the same name as the file. And then we'll create another group inside of that group and give it a name initialize. The first business requirement is if there's no user on disk, we show the user the welcome view. This requirement can be split into 2 unit tests. The first one is a basic interaction verification. We will check when the initialize function is called, we have to check has user on the shared preferences. This will force us to set up quite a few things in order for this test to even compile to start with. We'll start by creating the model that we'll be using, which is the startup view model. And as you can see, it's completely empty with some imports left from the tutorial when I finished it and then removed the code afterwards. Then we'll call await and we'll call the initialize function on the model. This function doesn't exist, and in TDD world that is already a failing test, so we'll write the code to make that section of the test pass. To do this, we will create the method using the shortcuts and assign a return value of type future to the initialize function. Then we will use the verify function from Mockito, and we will check if the shared preferences.hasUser has been called. Now at this point, this is as well another failing test because there is no variable called shared preferences yet. To make that failing test passed, we need to create a mock of the shared preferences. Go to the test helpers file under the setup folder where we will create our shared preferences service mock. This will be a class that extends the mock class from Mockito and implements the shared preferences service API. That's all you need for the basic mocking functionality. Go back to the startup view model test file where we'll now create an instance of our shared preferences mock and store it in a new variable called shared preferences. Click on the run code lens link above your test. This test will fail, of course, because there's no code in the initialize that checks with the has user on shared preferences yet. Head over to the startup view model where we'll add the code to make this test pass. The first thing we'll do is get the shared preferences service from the locator and store it in a final variable called shared preferences. Then in the initialize function, we'll create a new variable called has user, which will store the value from has user on the shared preferences. Go back to the startup view model test file and run this test again. This time the test will fail for a different reason, and that is because there is no instance for shared preferences registered with the locator. If you go back to the startup view model, we'll see that we're requesting the shared preferences instance from our locator. What that means for us is before we run this actual test, we need to register the shared preferences with our locator as a singleton. We'll call the locator and then we'll do a register singleton call, as well as provide the type of shared preferences that we are registering. And if you run this code now, your test should pass. So the usual pattern you follow when doing TDD or a TDD-like approach is red, green, refactor. We first write a failing test, then we get it to pass, and then we refactor the test that we've written as well as the code that was written to make it a bit better for the next round of testing. We know that the service will have to be registered before every test that uses that startup view model. So we'll go ahead and create a function in the test helper that will help us do that registration beforehand. We'll create a function called get and register shared preferences mock. It will return a shared preferences service, and we'll cut the lines from the test and paste it in the shared preferences helper. This will construct a new shared preferences service mock, register that as a singleton with the locator, and then return the service to us in case we want to use it. Now in the test, when we construct our shared preferences variable, all we'll do is call get and register shared preferences mock. You can run your test again to see if it passes, and with that done, we can move on to the second unit test for this first business requirement. Type test S and press tab, which will fill out the snippet for you. The second test will be when called and has user returns true, it should replace the current view with the home view route. The first thing we'll do is create a new variable called navigation service and assign that to a function called get and register navigation service mock. This function doesn't exist, so we'll go to the test helpers where we will create this function. The first thing we'll do is clone the mock class and change the name to navigation service mock. We'll also change the implementing interface to navigation service. Then you can copy the get and register shared preferences mock code and duplicate that and change the shared preferences section to navigation service. We can replace all the shared preferences service types with navigation service, and then we can construct a navigation service mock instead of a shared preferences service mock. There was a typo in my function naming in the test, so just add mock at the end of that. You can copy the startup model construction and initialize code from the top function, and then we'll verify if the navigation service dot replace with function was called with the home view route as an argument. Click the code lens run link and it should fail the test once it completes. This shows us that the shared preferences is not registered before we running this actual test. And that is true because we didn't call the get and register shared preferences mock function. But we also don't want to be forced to always call those functions before we run these tests. This is where test setup and test teardown comes in. We'll create a function in the test helper file called register services. In this function, we will call all of our get and register functions that we have in the current test helper. We have to make sure that this stays updated because that is how it works in the current app when you run it. The services are all registered before the app even runs. We'll create a second function which will be used for teardown called unregister services. This is where we will call the unregister function on the locator and pass in the types of the services that we have registered. We'll do that for shared preferences and for navigation service. Now we can use the setup and teardown functions. If you use the setup and teardown within a group, it will run before all the tests in that group. If there are other groups within that group, it will run before those groups are executed. We will call our setup in the main group that has the name startup view model test. This will mean that it will run before the initialized group is executed. So we'll create a new function called setup and pass it an anonymous function that triggers the register services function that we created in our test helpers. We'll do the same for the unregistered services, and that is all the setup and teardown required. If you run this test now, it will still fail with a different exception this time. Now it's telling us that the navigation service is already registered. This is true because if you look at the register services, we register the navigation service mock, and then in the test itself, we try to register that mock again and make use of it. To avoid this, we will unregister the current registered navigation service before we register the new one. For that, we'll create another function called remove registration if exists that takes in a generic type T. For the body of this function, we will check if the locator has a registered type of T, and if it does have a registered type, we will unregister that type. Then you can go to your get and register functions, and before we run the logic that we already wrote, we will call remove registration if exists with the type that it is returning from the function. Some of you might be wondering why we are just not checking if the type is registered and avoid registering the singleton again. And that is because some of the services will need to be set up within the unit test with values that will be returned. So we can't just register the old service and return that one because it won't have our setup. We have to construct a new one and create the stubbing that we require for the test to work and then return that one for that specific unit test. And if you run this test now, it will fail with the actual problem that we want to fix in code. And that is that the navigation service is not actually being called for anything. So navigate to the initialize function in the startup view model, and then we'll check if has user is true. At the top of the file, we'll create a new final field called navigation service, and we'll use our locator to get the navigation service. Then in the has user condition, we will call the navigation service dot replace with function and pass in the home view route from the routes class. Make sure to mark your function as async so that you can use the await word. So if we run this test now, you'll see that the test actually still fails. If you look at the exception now, it says that the Boolean expression cannot be null. This means that the has user value returned from the shared preferences is now null. Now we can actually take a look at stubbing with Mockito. We want to control the value that the has user property returns from the shared preferences service. To achieve that, we'll add an optional Boolean parameter called hasUser that has a default value of true. Then before we register the service, we will stub the hasUser property using the when function. We will say when this property is called, we will return the hasUser value as passed in through the optional parameters. Since the default value is true, we don't have to change this current test for that test to start passing. If you run the test, you'll see that it is now passing, which means that our logic is complete. Now we can move on to the second business requirement, which is if there's a user on disk, we have to get the current address for that user from the database. Go to the test file where we will use the test s snippet, and the test will be when called and has user returns true, should get the current address from the database. There's a typo in my test and I said current user, so you have to just use current address instead. Let's write our first line of failing code, which is creating a variable called database and then setting that value equal to the value from get and register database mock. Then we can copy the startup view model construction and initialize code. Then I'm just going to copy the function name for the database mock and navigate to the test helper file. We can then clone the navigation service mock and create a new class called app database mock, which implements the app database class interface. Then we can clone the navigation service mock helper function and replace the name with get and register database mock. This will return app database and will register an app database mock with a singleton locator. Then for the verification that this test works, we will check that the get current address was called on the database. If you run this test, it should fail, and then we'll go ahead and write the code to make this test pass. Before we forget, head over to the register services function where we'll call get and register database mock. And in the unregister services function, we'll clone the navigation service unregister and replace the type with app database. You can also run the Flutter test command to run all of your unit tests, and you should still see the same test failing. So open up the initialize function in the startup view model, and at the top of the view model, we will create a new final field called database, which will get the app database from the locator. Now inside of the has user condition, we will create a new variable called current address, and we'll set that variable equal to the get current address function from the database. Head over to the startup view model test and run this test again, and it should pass. Then we can use the test s snippet again and write the next use case for the business logic. This will be when has user is true and get current address returns null. We should call replace with and pass in the address selection view route to the navigation service. This will require us to modify the response of the get current address function call on the database mock. Because we are not checking any address values, we can simply create an optional boolean called return address, which will determine if we return an address object or if we return null for the function call instead. We'll give it a default value of false. We'll do the same when function call, and inside of the when we will pass get current address as the function to call. Then we'll use the .then answer function instead of the then return, which is what you use for future. When the return address is true, we return a future value with the address construction, and if it is false, we return null. Then the first thing we'll do in that test is make sure that the database instance that's registered returns no address by setting return address to false. Then we will create our navigation service and store it in a variable called navigation. We'll construct our view model and initialize that view model. Then we can verify that the navigation service has been called and the replace with function was called with the address selection view route passed to that function. If you run this test now, it should fail. Then you can go to the initialize function in the view model where we will check if the current address equals to null. And if it does equal to null, we will call the replace with function on the navigation service and pass it the address selection view route. If it is not equal to null, we will navigate directly to the home view route. You can right click on the test results on the left and choose start without debugging, and your test should pass. If you run all of these tests now, one will fail, and that is because the default value for the database function mock is returning null instead of an actual instance, which is what all the other tests were depending on. This is just to show you that the way you set up your mocks and which default values it returns is very important. Some people believe that there should be no optional values and you instruct the service whenever you register it what values it should return so that it's clear within the unit test which values it will be returned. This is a good approach as well, which I do use in some cases, but I didn't want to expand this test tutorial by having to write all of that code every time. If you execute the Flutter test command now, you should see 11 unit tests passing, and that is basically everything that I wanted to show you around mocking. If I had to continue with the other tests, it would look exactly the same as the previous ones, and I don't like tutorials that don't deliver value every minute of the tutorial. There is one thing that I wanted to show you, which is the fact that none of these classes have an actual implementation, besides the navigation service, which you can get from the stacked services. If you look at the app database, it's empty, as well as the shared preferences. Don't take this fact for granted, because it is a very powerful technique to produce rapid code development. You can basically develop all of the business logic as it's given by the spec, and leave the implementation to either the other developers in your team or for later on. It sets it up so that you can even develop when you have no network, no internet, you have no database set up, maybe you haven't even chosen your database yet. You can still develop your application and get all of the business logic done with unit tests, which you can run once your implementation has been completed. If you want to know more about that, you can go to the abstraction video that I have, where I show you how you can set up your locator to return either the fake values or the real values. This is for when you want to start developing your UI but you still don't have an implementation. You can return a fake implementation which has the exact values that you would need to develop the functionality that you're busy currently developing. I'm working on a new tutorial for this, which will use environment variables instead to set up your fake values. This means that you will have multiple profiles in your Visual Studio Code which will be linked to either fake or real data. This also means you can quite easily build a demoable version of your app to show to clients in case there is some feature that might require a stable network conditions and you are not in the best place to do that. This is my last intended video on the unit testing process for now. If you have any more questions, please let me know and I'll see if I can put it into another video. Thank you guys for watching, and I'll see you in the next one.